Hello everyone, welcome back to my channel. So today I will be starting the first lesson under data structures, and that is sorting. So before that I need to mention something, that is I will be using Java programming language in the upcoming lessons. That means to explain you the concepts under these data structures I will be using Java as the programming language. So let's come back to the lesson. Our today's lesson is sorting. And what is sorting? Actually, sorting is a very common programming process. Simply, sorting is putting unordered information into a ordered form. Like it may be alphabetical order, or it may be ascending order, or even it may be descending order. So there are several sorting algorithms. They are selection sort, bubble sort, insertion sort, merge sort, quick sort. So today I'm going to discuss selection sort. Okay, now let's see how to use this selection sort algorithm to sort a list which is not sorted yet. There are several steps, and the step 1 is the list is divided into two sublists as sorted and unsorted, which are divided by an imaginary wall. Here I have denoted sorted subarray and unsorted subarray, or you can say sorted sublist or unsorted sublist. And in unsorted sublist, you can see it is not ordered. But in sorted, we can say it is in ordered form because there's only one element. When there's only one element, we can say that it is already sorted. So let's see the second step. The second step is we find the smallest element from the unsorted sublist and swap it with the element at the beginning of the unsorted data. That means we check this unsorted sublist. Okay, here we check for the smallest elements in the unsorted sublist. As we can see, 23 is the smallest element in the unsorted sublist. When we find that smallest element, we have to swap that smallest element with the first element of the unsorted sublist, which is 78. That means after this process, 23 comes here and 78 goes there. Okay. Then, as the next step, we have to do this. Like it is after each selection and swapping, the imaginary wall between the two sublists move one element ahead, increasing the number of sorted elements and decreasing the number of unsorted ones. That means earlier 78 was here and 23 was here. Now those two are swapped. 23 came here and 78 came here. Now the next step is the imaginary wall between the two sublists move one element ahead. Earlier imaginary wall was here and the imaginary wall came to here. That means it increased the sorted sublist from 1 by 1. Now sorted sublist has two elements, 8 and 23. These two elements are in sorted form. That means 8 is less than 23, right? So it is in ascending order. And by doing that, by taking the imaginary wall one element ahead, the unsorted subarray or unsorted sublist was reduced by one element. Like earlier it had 5 elements, now it has only 4 elements. So it is 45, 78, 32 and 56, and they are not in sorted form. They are unsorted. So Each time we move one element from the unsorted sublist to the sorted sublist, we have completed one sort cycle. And a list of n elements requires n minus 1 sort cycles to completely rearrange the data. That means if our list has 6 elements, we need only 5 sort cycles to completely rearrange. That means completely sort the list. So let's see an example. After that, you will get a clear understanding about this selection sort. Just I explain the steps of selection sort algorithm. Now let's see this. This is an unsorted array. Unsorted array. That means it is not in an order. So this is called the original list, and I have placed the imaginary wall in the beginning, at the beginning, because there's no two portions as sorted subarray or unsorted subarray. Okay, in this example, in blue color, I have represented the sorted things, and in white color, I have represented the unsorted things. Okay, now let's do the steps we had learned earlier. Okay, now let's see what is the smallest element in this list. What is the smallest element? It is 8. So, as the theory, 8 must be swapped with the first element of the unsorted part. This is the unsorted part, and this is the first element, this is the smallest element, and these two will be swapped. So, 8 comes here, 23 comes here, and our imaginary wall will be moved one place, and it comes here, and this is the sorted part, and this will be the unsorted part. Sorted part was increased by 1, unsorted part was decreased by 1. Okay, now at the next point, we check this portion. In here, the smallest one is 23, and the first one is 78, first one of the unsorted part. And we swap these two. So 23 comes to that place, and 78 goes to that place. Okay, and the imaginary wall was moved one position, and sorted part was updated, and unsorted part was updated. Now we have 8, 23, and this part is the unsorted part, so we check this part. In this part, 32 is the smallest element, and 45 is the first element. Then again we swap those two. 32 comes here, and 45 goes there. Okay, 32 came here, and 45 went there, and the imaginary wall was moved one place. And just see, this portion is now sorted. 8, 23, 32. 8, 23, 32. This portion is unsorted. Okay, now let's see these three. In here, the smallest one is 45. 45, and the first one of unsorted is 78. Okay, 78. Now we have to swap these two elements. Then 45 comes here, and 78 goes there, and the imaginary wall come one position forward. Okay, now this is the sorted part, this is the unsorted part. Okay, now what is the smallest from here? It is 56. And what is the first of the unsorted? It is 78. So we have to swap these two. And 56 comes here, 78 comes here. So our list will be sorted, completely sorted now. Okay, 8, 23, 32, 45, 56 and 78. Now our cycles are complete. I said that if there are n number of elements in the array, we need only n minus 1 number of cycles to complete the process. See, it has 1, 2, 3, 4, 5, 6 elements, and we needed only 5 cycles to complete the process. That means to completely sort our array. So it is this. So next we have to see the algorithm. This is selection sort algorithm. So to understand any algorithm, the best thing we have to do is raise it. Raise the algorithm, raise the program. So I will be raising this algorithm, but not for all the cycles, only for the first 2 cycles. So you have to raise the rest. Okay, I will teach you how to do that. This is the same algorithm I showed you earlier, and let's see how the first cycle came. In here, I have taken an integer type array inside, and first I have created an a variable of integer type, and I have stored the length of the array in it. This is the example array I got to explain this algorithm, and it has 6 elements. So initially our n will be 6. Okay, let's go to this for loop. In this for loop, first the I value will be 0. So I have written it I equals 0. And inside that for loop, I have created another variable as min, and I have given the value of I for that. What is I? I equals 0. Therefore, min also will be 0. Okay, it goes to the next for loop. In this for loop, it is j. The variable is j. Okay, in here, the initial j value is I plus 1. Okay, j equals I plus 1. What is I? I is 0. So j will be 1. And this for loop will be iterated until j is less than n. What is n? N is 6. That means j is less than 6. Okay, let's go to inside of that program. Inside of that for loop. Okay. In here, there's an if statement. In this if statement, it states that if array min is greater than array j, this will happen. Let's see what is our array min. Array min. What is our array min? Min is 0. Array 0, it is 23. Okay. Array j. What is j? J is 1. Okay. 23 and 78. Is 23 greater than 78? No, right? Okay, so that means this will not happen. It will go to the next iteration because it can go up to j is less than 6. Okay, when we execute this code, it will finally get a value. What is that value? It is the minimum value of that list. I think you can remember the things I have told you earlier. Like we are finding the minimum of the unsorted list. Okay. Now, as the theory, this one is the minimum of the list. So our min value or our final j value must be 3. Okay, that means our min value must be 3. Okay. Now min value is updated. Min equals 3. Okay, you can raise it one by one slowly. Then finally you will get min as 3. Okay, alright. Okay, it comes out of this, and we'll check this. Is our min not equal to I? What is our min? It is 3. What is our I? It is 0. Of course, it is not equal to I. So this code will happen. In here, we have created a temporary variable as temp. Okay, it is integer type. Then I have equalized the value of array I to that temp. What is array I? Array I is array 0 because I is still 0. Okay, that means our temp value is 23. Temp value is 23. Temp value is 23. Okay, now let's go to the next line. It says that equalize the value, this value array min to array I. What is array min? We have to first check that. Array min. Min is 3. Array 3. What is 3? It is this. 8. So our array I is 8. What is I? I equals 0. Yes, we know that I equals 0. That means the value 8 must come to the position of array 0. Array 0. What is array 0 position? This first position. So this 23 will be removed and 8 will be replaced. Like in here. Okay, now in the first position or the 0th index, it has 8. Alright, then let's go to the next step. In here, it says that equalize the value of temp to this position. Okay, now let's see what is temp. We know that our temp is 23. How we got that? From the first line. Temp is 23. So we are saying that put this 23 to array min position. What is array min position? In this instance, our min is 3. What is array 3 position? Array 3 position is this. It says that put 23 to this position. Okay, that means this 8 will be removed and 23 will be replaced. That means 23 come here. Okay, that means 8 comes to index 0 and 23 comes to index 3. If you can remember the early theory, you will get this. The thing happened was, we first checked the minimum from the list and swap it with the first element of the unsorted list. 8 came here, 23 came here. Okay, this is the first cycle. Okay, let's also see the second cycle. Now, it is the second iteration of this for loop. Okay, that means in the second iteration, I equals 1. Okay, I equals 1. And min is also equal to 1. You know that. And the j value will be I plus 1. The initial j value, okay? Initial j value will be I plus 1. Right? Okay. Now j equals 2. In here, see here, array min. Array min. Okay, let's come to here. Okay. So we came to inside of this for loop and there's if condition. It says array min if array min is greater than array j. Okay, what is array min here? Array I, because min is 1 and array I is 78. This is the update at least. Okay, the 8 and the 23 has swapped. Okay, our 1 is 78. Array j, what is j? Our j, it is array 2, it is 45. Okay, now we check this. Is array min greater than j? 78 is greater than 45. Yes, it's true. So our min value will be what? J. It is 2. Okay. Okay, now let's come to again here. Now j will be updated by increased by 1. Now our j value is 3. Okay. When you iterate this for loop again and again, slowly, finally you will get the minimum as 3. That means our j will be 3 and so that our minimum will be 3. Okay. See here, from these positions, from this part, what is the minimum? It is 23. What is the index? It is 3. That is what we got. Okay. Now minimum is 3. Okay. Let's see. Now we exit from this for loop. Right? They say that if minimum is not equal to I, of course minimum is not equal to I. Minimum is 3, I is 1, so they are not equal. So these codes will be executed. Okay, let's see. In here, they are saying that put the array I value to the stem. What is array I? Array I. Array, what is I? I is 1. Array 1, what is what? Array 1, it is 78. Okay, now our temp value is 78. Okay, right. Then we come to next. It says that put array min value to array I position. What is array min value? Array min. What is min? Array 3. 3. What is array 3 value? It is 23. Put 23 to array I position. What is I? I is 1. What is array I position? This is the array I position. They are saying that put 23 to that position. So we cut this 78 and we put 23. Like here. Now in array 1 position we have 23. Okay, let's go to next step. In here they are saying that put the value of temp to array min position. What is temp value? It is 78. We found that in this line. It is 78. So we put this 78 to array min position. What is min? Min is 3. What is array min position? It is this position. So it has 23. We cut this and put what? 78 to that position. Okay. Now the 78 come here. Now it is 78 in array 3 position. Okay. Now, 78 comes to index 3, 23 comes to index 1. Just see. Okay. In the second cycle, our imaginary line was here. This is our unsorted array. What we had to do? We have to find the minimum and swap it with the first of the unsorted array. What is the minimum of the unsorted array in here? It is 23. It was swapped with the first element of the unsorted array, which is 78. And the changed array is this. This is the end of cycle 2. Okay. Now, your responsibility is to do this again and again. Like, you have to complete the rest and do it again and again. So you can get a clear knowledge, very clear knowledge about selection sort. So this is the end of the first tutorial under data structures. So I hope to continue this sorting algorithms in the upcoming videos. And thank you so much for listening.